Somebody grab the door, please. Okay, so I got a bunch of stuff to cover in this breakout. I almost wish it was about 4 hours long, and then I might have enough time. And then Davey's going to be coming in at the end to talk about some of the logistics over the next couple days. But I want to introduce you to Knex.js. So Knex is a library that sits on top of the things that we looked at this morning. So it, behind the scenes, would use a library like PG or MySQL or SQLite 3 or something like that for talking directly to the database. But what Knex does is it gives you that extra layer of abstraction on top to make it easier for you as a developer to work and build your business logic. And so it ends up being a really powerful tool, but it is one of those things that initially, most developers who run into Knex initially run into it quite the way that you would a brick wall, as opposed to, you know, a beautiful spring day. So I want to try and demystify Knex just a little bit for you. And then there's a really key piece of Knex that it includes that is a standard practice when it comes to databases that I want to introduce you to, called migrations. So let's start off and look at how Knex works with an existing database. So we're going to work with the same database that we worked with this morning with the hockey players and the teams, because I want to demonstrate how we would do some of the same things that we did with just regular straight SQL using Knex. So to begin with, let me get this large enough again. I'm going to just give myself a package.json file. Now, Knex, interestingly, is one of the NPM tools that you'll run into that you want to have installed globally. So whenever you first start working with Knex, you're going to want to do the npm install -g Knex so that you have Knex just as a command line tool, because you're going to run a lot of commands that are Knex space something that will help you to manage your database and manage your connection and everything else. So you need to have that tool installed globally, but I'm also going to want to have it as a dependency in my project, so I'm going to do an npm install Knex, which is going to go really quickly because I have it installed globally. Now, once I've done that, now what I can do is I can run the command knex init. And the same way that npm init is going to start me off with a package.json file, pardon me, there'll be another one in a minute. What Knex init is going to do, as it has told us in green, is it's going to create what's called a Knex file. And if we open this up and look at it, it allows, basically it's just, told you, it's just a module in JavaScript. It's exporting an object. And this becomes our configuration object for Knex, for actually connecting to our database. Now, the cool thing about the way this is set up is that it's set up as an object. In this case, we've got 3 keys. We have development, staging, and production. And each one is an object that just has some extra config in it. But what this does is it introduces the concept of environments. And environments are really important to us as web application developers. So here's how environments work. When I'm developing here on my local machine, I'm going to have a development database. I'm going to be, probably throwing a whole bunch of stupid values in there. I'll make up, names of, users that are clowns or serial killers or whatever, clown serial killers, which sadly is a demographic. But I'm going to come up with, some fake data that I'm going to be working with. I'm probably going to test inserting the same user 50 times to make sure that it works. That's not going to be a clean production database. And there's no guarantee that the same software that's running on the production server is going to be running on my local machine. With something like Vagrant or some other virtual machine, I can try and emulate that same environment, but I can't be guaranteed that it's exactly the same. So for example, as it comes out of the box here, with development, I might be using SQLite 3, but on the staging testing server or the production server, we might be using Postgres. So, and I would have different connection parameters for that. So what environments allow me to do is it allows me to set up specific configurations depending on which environment my app is running in. And this is a standard thing that you'll run across with databases and frameworks that you'll use from now forever, is just having this idea of different environments so that theoretically, as long as you know what environment you're running in, you can connect to the right database and be able to work with the data you have. Now, in order for me to get this to work, I'm actually just going to borrow the Postgres stuff because that was what we were connecting to before. So the database name there was hockey, and username was Don, and there's no password. So as we can see here, Knex automatically takes advantage of the pool capability. So I will always have a minimum of 2 connections available and a max of 10. I can configure that bigger or smaller if I want. And like I said, we'll get to migrations a little bit later. And all I've really done is, for the purpose, by default, I'm always in the development environment. That's the default unless I specify otherwise. So that's the only one I'm going to configure for right now. So once I have that Knex file, now I can use that as a module to configure Knex with. So here's what I'm going to do. I'm going to make another index.js file. And what I'm going to do is I'm going to require Knex in, and I'm going to, well, actually, no, I'm going to do this first. I'm going to require in my Knex config. And then what I want to do is I want to configure Knex according to the particular config I want. So I'm going to use my node env for doing that. Now by default that should be development, and in fact if we look at how they're doing it when they initialize it in the documentation, they're actually just passing an object directly to it, but the Knex file is effectively going to do the same thing. One of the things that's often a very good practice is to just set up an environment for yourself, just a default variable, so that if your node environment isn't set, you just default it to development, and then here I just use that. So that's going to look up in that object whichever environment I'm in, development, staging, production. I could configure other ones. I could have one called testing. I could have one called Bob's Basement, like whatever it may be. And then I can have a specific configuration for that and load Knex in. And what that gives me is an object that I can now run queries with. So one of the things we had before is we had basically the select star from Teams. And so for me to do that with Knex is pretty easy. By default, that's select star from Teams. So if I run the Knex function and I just pass it a table name, that's by default going to select everything from that table. Now, where things get a little bit, how do I say it, different with implementing Knex is how you get results. So if I just do this, and in fact, let's just do this. No, oh, because I'm a dork. Really? Fine. So what we get back is this big object. And this big object doesn't really help me much because I can't see anything in here that is my results. And that's because Knex requires you to go one of two directions when you run a query. It either requires you to use promises that you haven't learned yet, or it requires you to specify a callback function, which fortunately you know callbacks, and that's kind of the standard pattern in Node anyway. So what I'm getting back from this is just a Knex object that hasn't even actually run my query yet. This is just my Knex query builder object. So what I actually have to do is this. Look familiar? Error first callbacks. You know, that's, well, let's do that a little bit better, but there we go. So very similar to what we did before. In fact, shockingly similar to what we did before. And now when I run this, that looks familiar. My rows come back as an array of results that are JavaScript objects. Yeah, so that's the basic pattern that you're going to want to follow anytime you do a query in Knex. You're going to do dot as callback and pass a callback function to it that will handle your results. Your callback function should take two parameters, an error object and the result set, and then whatever you're going to do with the result set, there you go. So if I needed to look up players or teams or any of the things I was doing before, I would simply add dot as callback at the end and pass it a callback function, and that's how I work with my data. So if we look at, so we had getting the players by the team. Players, and then Knex gives you a pretty decent amount of documentation on how things work. So they have a join builder. So for example, here's Knex users, so that's selecting from the users table. .join contacts, users ID equals contacts.user ID. So we can join teams, and what we're joining on is teams.id equals players dot team ID, and then where teams dot name, let's say Knex, and we can, by default, it will select everything. And here's the interesting thing. Knex doesn't care what order we put these clauses in. We don't have to build it in the order that we normally would with a, like in a SQL query, because we're just running methods and Knex is a query builder. So until we actually run as callback, it's just building a query and assembling the different clauses of it. So here, I can select, for example, players.name, players.position. And then down here, I can do as callback, error rows. Let's assume I did the if error. Rows for each player, console.log, player.name, plays, player.position. And that's now my same query that I built before. But I've done it now with JavaScript methods as opposed to doing it with manual SQL. And when I run this, there's my teams from earlier, and then here's my players on the Knex that I was able to get access to. Literally same output that we had before, just a slightly different interface for actually approaching the query. And so there's join methods, there are where methods. For example, I can pass an object to where, and that's where first name equals test and last name equals user. One of the things that's nice about this is it shows you actually what the query is that Knex would output. Knex users where ID 1. Select star from users where ID equals 1. Now, one of the things I will tell you is that as long as you are using where this way, where you are passing the field as the first parameter and the value as the second parameter, Knex will automatically parameterize the queries and therefore keep your queries safe from injection. Where the challenge becomes is if I was to write something like Knex players where position equals C. That is not parameterized. And in fact, what would be even worse is if I did something like, let's turn this into a template string and said, you know, rec.body.position, where I interpolate directly into the where clause. Never, ever, never, ever, 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 never do that. Like, this is the thing you tattoo on the inside of your eyelids to never, ever do. This is bad. It seems like a great idea because it's nice and easy. It's in the rec body. I need it in the query. Ta-da! But this is guaranteeing SQL injection when you do this. So this is what you never, ever want to do. I'll leave that as a caution to the wise there. Other things that you can do, we have where not. So we see that if we pass the same object of first name test and last name user, select ID from users where not first name equals test and not last name equals user. So this would give us everybody except test user. Where in, where not in, where null, where not null, where exists, where not exists, where between. Basically anything that we would write as a manual SQL query with where, there's a method for it. Where raw is interesting because that allows us to write manual query like manual SQL, but we can still parameterize it as long as we follow the same thing. So instead of $1, now we're going to use question mark. Question mark is actually far more traditional to use for a parameterized query, and the question marks are just replaced in order of how they appear in the array. So the first question mark gets the first element of the array, the second one gets index 1, et cetera, et cetera. So the other thing that's nice is any other clause that we would use in a query. Distinct, group by, order by, offset, limit, insert, we can insert directly in. So for example, Knex books dot insert title Slaughterhouse 5. That inserts a new book into the table where the title gets set to Slaughterhouse 5. Once you understand the basic pattern of Knex table name and then methods to build on the end of that, it starts being a lot easier to work with Knex. Del is a good one to know because .del deletes records. Be careful with that one. General rule is to never, ever write a delete query without a where clause, because otherwise you're just nuking everything. You can imagine what this does. Nothing good. This would nuke 888 players all at once. Don't do that. So always have a where clause. Any of the aggregation functions, count, min, max, sum, average, those are all there for you if you want to use them, and they're going to do exactly what you would expect them to do. Knex users.average age will select average age from users. And what's interesting out of that, if we look at, let's take a number like shots. Sure. So if we do Knex players.average shots as callback, pair rows. Now I just want to show you how this is going to come back. Let me go ahead and block these out so that they're not running. So that's how that's going to come back. I requested the average, so it's going to try and prettify the key name for me just a bit. So it's going to give me one row back, because that's what an aggregate query would do. It'll give me one row back. The key will be called average because that's the function I ran, and then the value will actually be a string that is the average I requested. Things to be aware of. And that is still a row that was returned, so I'm getting it back in an array. So things to watch out for. Same thing like if I did a count, for example. Knex players, you know, for example, let's say I count the IDs. I'm going to get back count and 888. So whatever the function name is that I ran, I will get that back as my key. But I do also have the ability, if I find it down here, yeah, there's a .as function. So I can set things, you know, .as if I want to set an alias on it. So here I could as, let's say, num players. Oh, and it didn't do it. Why didn't it do it? That should have done that. And I don't know why it didn't. Oh, that's only for subqueries. Never mind. Ah, my apologies. Yeah, it's just going to be count. There's pretty much, unless I did a raw, select raw, unfortunately it won't let me change that. That's only for subqueries. That's dumb. Never mind. Aha. So if I wanted to do that, there's a couple ways that I can do this. One is I can use raw, like select raw, to write a SQL function that will do the rounding for me, or I run my query, and when it comes back, I would do something like row 0 to fixed to row 0 dot 0 dot count dot to fixed to. I would just pluck that data out of the object. What? Oh, because it, yeah, it's not. Sorry, I forgot to cast it to a number. You can't call toFixed on a string. And then I would get that. That answer your question? I just have to run code on it. There are SQL functions that will do rounding for you, but then I'm in the position of having to write raw SQL queries inside Knex. And Knex has a raw method, so there's like where raw, select raw, insert raw, so that I can just put raw SQL in there and it will build the query out of that. But when I'm selecting the count, I would have to select round count, comma 2 to, or however many decimal places I wanted in order to get that. So it just means me writing more manual SQL. Cool. So that brings me to the halfway point. So now I want to talk about migrations. Migrations are a big deal. And they're a big deal because most major database libraries give you a tool called a migration. And when we think migration, we tend to think of like birds or butterflies or something like that. But what a migration actually is in this context is me taking my schema for my database and migrating it from one version to another. So everything that I've been doing here is based on the idea that I have a pre-existing database that has data in it, tables, fields are already set up, and that I'm going to connect to it and then just run queries on it. But what if I'm starting from scratch? Or what if I am adding features to a product and I need to add tables or change fields or do something like that? I need to have a tool or a way that I can change the schema of my database, but more importantly, it needs to be something that is reproducible by other developers on the team. So let's say, the three of us are working on a dev team, and let's say I go into pSQL and I run a whole bunch of like create table or alter table commands to set up what the schema of the database is. How do you guys get that? There's no easy way for me to pass that on to you and have it be exactly the same as what I created. So libraries like Knex and many, many other database libraries that you're going to run into have this process called a migration. And what it does is it allows you to script the changes to your database. And specifically the changes to your database schema. With my hockey teams here, let's say I was going to add another table for coaches. how would I do that? That's that's the challenge. And so if I wanted to have coaches, yes, I could totally come over here and I could create table coaches and set all the fields in there that I wanted to have. But then unless I gave those SQL commands to somebody downloads my project off GitHub or something like that, they have no way to reproduce what that schema of my database is. So the really cool thing about migrations is not only that you get to script the maintenance of your database schema, but because they are done in order, like each one has a timestamp on it, so therefore they can be done sequentially. That means if somebody does download my project off GitHub and they run the migration scripts, as long as they run them in order, what they end up with is their database schema will be the same as what I have as my database schema. So it's literally handing someone a recipe that if they follow the instructions and reproduce it, they will get shepherd's pie or lasagna or whatever it was the recipe was for. And that's a cool thing, because that allows us to now open the door for being able to share our projects out with other people and have them develop on them, have them collaborate, have them, help in the process, or even just run them and enjoy them. So Knex has a whole suite of tools for migrations built into it. And in the documentations, it's down here under migrations, and it says it allows for you to define sets of schema changes so upgrading a database is a breeze. So there is a command line interface for the migrations, which is one of the reasons it's important to have Knex installed globally. So I have this command, Knex migrate make. And when I do that, I give it a name, something like Knex migrate make create coaches. And when I do this, it tells me it's using the development environment, and it has created a migrations file for me. So now I can access this file, and I notice that there's some code here already built for me. And this is important because these two functions have very particular meaning. Up and down is a convention that you will see in a lot of migrations because they provide the ability to move forward and backward in the timeline of your schema. So up is the code that will run in order to apply this migration or make this database change. Down is the function that will run in order to reverse that change. So you'll see up and down a lot with database libraries. In this case, I'm creating coaches, so theoretically in my up, that's where I'm going to put the code that would create my coaches table. Down is going to remove the coaches table because that would undo this migration. So up is do, down is undo, is the easy way to think about that. And when I am looking at running this, once I actually build the migration, I run Knex migrate latest, and that will run all of the pending migrations that are available. What Knex actually does is it creates its own tables for keeping track, like in your database, for keeping track of the migrations. So it knows which migrations have been applied and which ones haven't. And so then if I run Knex migrate rollback, that would undo the migration, the last one that I just did. If we look at, where did it go? Schema Builder. Schema Builder gives us all of the commands to be able to create and modify schemas in our database. So for example, if I wanted to create a table, which is what this migration is for, what I'm going to do here is I'm going to return Knex schema create table, coaches. And then we can see that it gets a callback function with one parameter. And this table object, or that the parameter that's being passed in, represents the table that I'm going to create. And so then I can do a few things, like table.increments creates my primary key for me. So that will automatically create an ID field on that table that is automatically set to auto increment each time I insert a new record. So I would do that. Then any other fields I want, for example, table.string, the name of my coach. Table.timestamps will add my created at and updated at columns and have them automatically update with the current timestamp. So when that record gets created, it will automatically get a created at field, and updated at will get created at the same time. And then any time that record gets changed, updated at automatically gets updated so that I see the timestamp of the last time that record was touched. That's something that you will see quite frequently. But one of the things here is that if I'm going to have a coach, I need that coach to be connected to a team. So what I want to do is I want to look at how I would connect a field in my coaches table to my teams table. So I'm going to want to create an integer field that is my team ID. So if I look at my lists here, I've got integer. So I can add an integer column, table.integer team ID. But I also want this to be a foreign key. And so what I can do, here's an example, table.integer user ID.unsigned. And then I can say table.foreign user ID references some other field in another table. So table.foreign team ID references teams.id. And if I find it, there it is, references, sets the column that the current column references as a foreign key. So I can actually chain these if I want to, but I'm going to do it as 2 lines just to make it nice and clear. So here I'm giving my coach a name, I'm giving the coach a team that they are associated with, and making sure that that team ID is a foreign key pointing to my other table. Now, my down is nice and easy. I just need to drop the table. And I can double check that that's actually what I want to do by looking up drop table. And there we go. So that the up is going to create this table, and the down is going to drop it. And so if I run Knex migrate latest, it runs that migration. And now I can come over here and look at coaches, and there's my name, my team ID, my created at, my updated at, and I can see that coaches team ID foreign, team ID references teams ID. So I can see in my schema that that has immediately taken effect. And now that means I'm able to write code that is now working with this coaches table that I didn't have before. So the way this gets really, really powerful is, let's say hypothetically tomorrow I was about to start a big 5-day project. I know this is a stretch, but work with me. So I'm about to start this big 5-day project that has no existing database with it to start at all. So I'm probably going to spend some time, and Crum will go over this with you guys tomorrow, focusing on my database design. What are the tables that I want to keep track of? What are the fields that I want to keep track of? And then I can sit down and write some migration files that will build those tables for me. And so I run my migrations. I have some initial tables to work with. I start coding. Thursday, maybe Friday comes around. I realize, oh, you know what? I need another column on my users table. Great. Make a new migration. They're free. You can have as many of them as you want. They should represent how your database evolves over the course of building your app. You should never assume that you only get one set of migrations and then you're done. And don't fall into the trap of, well, it has to be perfect from the beginning. You can have 500 migration files for a project, and that's okay. Because you may add columns, you may drop columns, you may change column types, you may set up defaults for them. Like all of these things, there are methods in the schema builder for configuring your table exactly the way you want it, and that will evolve over time. And Knex will just iteratively apply all these changes when you run Knex migrate latest. So let's say I build this entire app, team's working with me, we're now back to being a team here, front table, and for whatever reason, your laptop gets dropped in the water. You thought about playing Frisbee with it for whatever reason and landed in the water. So new laptop comes in and you're like, oh crap, my project. You check out the repo, you run Knex migrate latest, and it will apply all those changes iteratively up to the point that you were when you stopped working. You lose nothing at that point, other than $86 billion for a new Mac. But you would lose no development time. You would lose nothing on the project because it would just bring your database up to the current schema at that point. So that's where migrations really get powerful, is the ability to have them work with you. And if I run migrate rollback, that's now going to run that. It's going to run that down. And if I go to look at coaches, there is no relation coaches because it has dropped that table. So I'm able to now programmatically manage my schema instead of having to worry about the awkward syntax of create and alter table statements, which honestly suck to type out. Like, they're the worst. I'd much rather write it in JavaScript because it's easier. So migrations are really powerful. Knex also gives you something called seeds. And seeds are how you provide initial data to your database. So let's say I was building a hockey app and I wanted to seed it with the initial 31 teams in the NHL. I can write a seeds file, which I can come down here and show you, with the seed API. That basically what it's going to do is it will allow you to just set up an array of objects that will automatically get pumped into whatever table you want. And in doing that, the really cool part is you have the ability to set up initial data. A lot of times, for example, apps have that, we know that terrible select box that has the list of every country in the world in it. Well, you're not going to type that out in your code. That's probably going to be sitting in a database table somewhere. And literally you can go and look it up online and it will just give it to you in JSON. So you dump it right into a seed file and you run that seed file, and then when your app gets initially set up, ta-da, you have one command in there that's knex.seed.run, and it just seeds all that into your database table the way you need, and that gets the initial seed values of data in your database that you need. So this ends up being a really powerful tool. Now, Knex is not the only one that is out there. It just happens to be one of the more popular ones. There's another one called Sequelize. There's a really good one that, had you asked me 9 seconds ago, I could have told you the name of it. I just saw it at the London conference. Hold on. I tweeted about it, so... Massive.js, that's the one. So Massive is a competitor to Knex. They're all open source projects, but it does things a slightly different way. It has a slightly different query syntax. At the end of the day, it's just a query builder library that does what you want to do. Interestingly, Massive doesn't have joins in it because it allows you to set up what's called a view, which is a prepared query. So you would just write out your SQL query with the join in it, and then you could run that as a function anytime you needed to. And that does exactly the same thing. So Knex is a really great one to start with, though, because it's so straightforward, it's clean, it does exactly what you want. The common rookie mistake that most people make with Knex, though, is forgetting to use .as callback. Because that, otherwise you don't have access to your data. In fact, Knex hasn't even run your query yet until you actually call .as callback. The other version is with promises, which is .then. And we'll talk about that more later this week, next week. Or not next week, week 6, with promises. Any questions up to this point?
A little bit fuzzy on why we, instead of actually writing everything at the time.
Yeah, so why we would use migrations. Otherwise, we'd also have to maintain a SQL file that would have all the commands that would need to be run to manage the state of our schema. This way, we can keep it all in JavaScript. And it also allows us, like having that Knex migrate latest means that there's a nice easy command that we could script into other things like deployment scripts and things like that, so that, let's say, every time we push a new build, instead of having to run the risk of importing a SQL file, we can just script in this Knex migrate latest, and it just runs and kind of safely takes care of everything with less risk than writing directly to the SQL. Plus, it allows us to do things like potentially add some JavaScript logic in there, like based on environment, we might have certain things in our schema that we might not have in other cases. One of the things I've seen with migrations is it would go out and it would actually request data from an API, and then based on the fields that the API is sending back, it would just iteratively build fields based on that. So you can just use JavaScript logic to maintain your schema, and it keeps it way more consistent. And it's just easier than writing SQL. Yeah. Other questions? Yep. You can just have multiple. So you can either pass one. So if you have multiple conditions on a where, you can either pass an object with key value pairs to .where, and it will automatically do an and. But if you have a little bit more complex, like where this and where not this, you would just have like .where, key value, .where not key value, .where in key value. So you can chain all those methods infinitely. You could also just do .where key value, .where key value, .where key value, and just keep building it that way until you get all of your where clauses built up. And by default, Knex will always do them as ands. You do have the ability, if I get back up here to where they are, if I remember correctly. No, actually, sorry, this is a bug, or not a bug, but a feature that's proposed. If you wanted to do an or, you still would need to do that using where raw, where you're actually writing the clause directly in there. So if you wanted to have like where this or where this, you would need to write that in directly, but they are working on an or where method. So that will come out in a later version of Knex, but it is on its way, because that is a logic that some people would want. But right now you have to do that with where raw. But yeah, you can just keep all the SQL methods, you can keep chaining them as much as you want. Because that's the nice part about it being a query builder library, is until you actually run .as callback or .then, it's not going to run your query, so you can just keep building it and adding clauses to it. and it doesn't matter which order you put them in. You could have your group by first and your count last, and different things like that. So yeah, the flexibility is really nice. Cool. Let me ping Davey and let him know that we are ready. Yeah.
With migration, managing this.
Yes.
So, what about the data for your play?
So the question is, when you're doing migrations, what happens to the data as you are changing schemas? So you're going to run the same risk that you would with doing it manually through SQL. So let's say, for example, I have a string field and I change it to an integer. Hey, Davey. If there's stuff in there that doesn't convert to an integer, it just all becomes zeros. If I drop a table, all the rows are gone. If I want to keep that data, I would have to run a separate bit of code to run a query on everything in that table and then log it out. Like you save it out to a file or put it in another table or something like that. So yeah, I would have to, and that's going to happen with every single library and framework. Anytime you're changing schema, if you run the risk of destroying data, you have to manage backing that up some way. Yeah. Cool. All right. Victoria, let me know if you guys have any questions. Otherwise, I'm going to let Davey talk to these guys about some of the chaos that's happening here. Cool.